Hi there. Just wanted to make you guys a quick video just talking about this week's learning. All the folders I think are ready and open, and term 3 is over officially and term 4 is starting. So this is today's lesson, and there's a note set to go through and take notes on. And I am going to kind of talk you through it with a video. So if you're not interested and just want to take the notes without the video, that's fine. But I'll just kind of do it as if I were kind of in class with you. So we're going to start talking about different types of chemical bonds. And we know that things bond to one another just to become stable. And usually that's to have a full outer level of valence electrons. And usually that's an octet or 8 valence electrons. There are some smaller atoms like hydrogen and helium that are fine with just having 2 electrons in their first level, which is the duet rule. So here's just an example of an ionic bond where sodium will lose this electron, give it to chlorine, then chlorine will have the 8, and then sodium will have 8 also. So when the sodium loses that electron, you got to remember it's losing a negative. So now it's going to have more protons than electrons. So it'll have 11 protons and 10 electrons. That's why it's +1. Chlorine now, it has 17 protons, but now it gained an electron, so it has 18. So we call sodium a cation for being positive, and chlorine is an anion. And then they are oppositely charged, so they're attracted to one another. The valence electrons for each column, if you don't have this labeled on your periodic table, I would recommend writing like 1E above this column, 2E, 3E, 4E, and so on. So the noble gases have 8 valence electrons except for helium, which only has 2. And then the transition metals in here, we can't just say that one vertical column all have the same number of valence electrons, so we don't label those. So metals are going to have fewer valence electrons than nonmetals, and they have, if you guys remember back to the periodic table, they have low ionization energies because they're wanting to get rid of an electron, and then so it's easy, it doesn't take much energy to pull one off, so they tend to lose electrons. So 3 or less valence electrons typically, metals will lose electrons and become cations, and nonmetals will usually have 5 or more and gain electrons to form, I think I just said anion for metal, but I meant cation for metals and anions for nonmetals. So 4 valence electrons like carbon, that's, what are they going to gain or lose? Sometimes they can do either, or they're not even going to gain or lose. They're going to share electrons, which is what leads us to covalent bonds. And covalence, we talked about compounds. We named them and all that. Remember all the mono, di, tri. So between 2 nonmetals, when they bond, they share electrons, so they can both count those electrons towards their outer valence electrons. And covalent bonds can be nonpolar covalent, where they're sharing really nicely and equally, and then they can also be sharing not so equally, where one of the 2 atoms in the bond will pull on the electrons more than the other, and that's called a polar covalent bond. And so the analogy I use a lot is with like a blanket. Someday when we don't have our social distancing, you can go like to a football or soccer game with a friend, share a blanket. The electrons would be like the blanket is the analogy is that the blanket is the electrons. So, and each of the girls is a different atom. So a nonpolar covalent is when they're sharing the blanket equally. Polar covalent is when one of them, this one, is pulling more, so they have more of the electrons by them. And then, and then I don't know why we have 2 nonpolar covalents, but the difference between nonpolar and polar covalent. So metallic bonding This would be like if you just have a piece of a metal, like I have you know, a gold wedding ring, or, you know, a metal pan or anything. It's the metal, like let's say we're talking about gold, it's the inner electrons in the nucleus, which are kind of held like in a crystal with these, you know, really ordered kind of rows and everything. But then the valence electrons are free to move about. Like, so if this gold, if that's its valence electron, it's not really. So really that valence electron that originally could have came from over here, because they're just easily kind of moving around throughout the metal. So we call that a sea, like, you know, going out into the ocean. So it's like water kind of flowing of valence electrons. So properties of ionic compounds and then covalent compounds. Ionics tend to have high boiling and melting points, so they're usually solids. And covalents typically have lower boiling points and melting points than ionics, but if it's polar, it's going to have still pretty high. The nonpolar covalents are going to have the lowest of the melting and boiling points. So the reason ionics, you have to break all of those attractions between the cations and anions in order to melt it. For a polar covalent, you do have the partial positive and negatives of the molecule that you have to break, and then there is no positive and negative for a nonpolar covalent, so that's why those are pretty weak. Solubility in water. Water, if you remember, when we know water is H2O, the oxygen end of the water is very electronegative, which means it pulls on the electrons and really hard. So the electrons tend to kind of accumulate on the oxygen, which then kind of leaves these guys without much electrons, so they become partially positive. So this is that blanket analogy where the oxygen's pulling on the blanket and the hydrogens don't really have much. Because of this water being partially negative and positive, that's why ionic compounds, which are made up of cation, anion over and over, the water will actually like surround each of those ions, and, you know, the negative end of the water is going to be attracted to the cation, and because opposite charges attract, the positive end of water would be attracted to the negative or the anion. And when you don't have ionic, or if it's not polar covalent, nonpolar covalents and metallics just tend not to be soluble. They don't want to dissolve in water. I'll let you guys watch this video later. This is just talking about that polarity of water again. Negative part. This is like a Greek letter delta, so just a partial negative charge on the oxygen and a partial positive on the hydrogen. It's not a full negative and full positive, then it would be an ionic, and it's not an ionic compound. So conductivity, looking at whether we know that metals conduct well because of those free moving electrons. Ionics will, if they're dissolved in water, they also conduct because they have positive and negatives, which can move and kind of close like a circuit. And then covalents don't have any ions and the electrons aren't able to move, so they tend not to conduct electricity.